All right, welcome back to 9.5, and we are looking at sum and difference identities today. Just like in the previous two lessons, we are going to be solving equations and proving equations, but we're also going to simplify the expression a little bit today as well, okay? So here we go, sum and difference identity. So you can see it's called sum and difference because it's addition and subtraction difference of two angles, okay? So this I think is where students often make mistakes. Um, Again, I think I've shown you this before. This is not the same as sine of alpha plus sine beta. Okay, they are not the same thing. You can't do that. Just like log, right? Log of a plus b is not the same as log a plus log b. Okay, it doesn't work that way. The proof for these identities is a little bit more involved, so I'm not going to show you. But if you're interested, you're definitely more than welcome to come see me, and I'll show you. Okay. Um, yeah. So here we go. And actually, it's not just these four. Okay, it's not just sine and cosine. There's also tangent, which we can actually prove quite easily using the sine and cosine sum and difference identities. Okay, so we can use these identities when we're looking at these type of questions. If we're looking for the exact value of sine 75, so far the special angles will be like 0, 35, sorry, not 35, 35, 30, 45, 60, 90 degrees, and so on. Okay, those are our special angles, but we don't have one for 75. However, I do notice that 75 degrees can be rewritten as sine of 40 plus, what am I talking about? 45 plus 30, right? And 45 and 30 are both special angles. So then from here, then we can use the sum identities to actually evaluate this. Okay, though we're going to do it, we're not going to do it right now. We'll do it later, but we can actually break 75 degrees into two different angles in which we can actually use the sum identities to evaluate. Okay. Okay. Anyways, this okay equals the blah blah blah. Again, we will do that later. Okay. But for the first example, this is what we're going to do. Okay, so here it says, given the angle alpha in standard position with its terminal arm in quadrant 4 and cosine alpha is 1 over 4, and angle beta in standard position with its terminal arm in quadrant 3 and sine beta is negative 2 over 5. We are looking for the exact value of sine of alpha minus beta. So just one more thing before we actually continue. Recall alpha and beta. Okay, these are two angles. Okay, alpha and beta, they are angles. Okay, so just like our example here, we have alpha in quadrant 4. So here is my alpha, and here's my triangle. Alpha is adjacent. Sorry, cosine alpha is adjacent over hypotenuse, so 1 over 4. We can find the opposite side by using the Pythagorean theorem. And it says angle beta is in quadrant 3. So here is my quadrant 3. Here's my angle beta. And it says sine of beta is opposite over hypotenuse, so 2 over 5. And again, we can find the third side, in this case the adjacent side, again by using Pythagorean theorem. Okay, so I have my two triangles ready. Then we can actually evaluate sine of alpha minus beta. Okay, and again, by looking at the identities here, sine of alpha minus beta is equal to sine cosine minus cosine sine. Okay, so it's going to be sine alpha cosine beta minus cosine alpha sine beta. Okay, and now we can actually figure out the ratios, okay, individually for each angle. Sine alpha, so we're looking at this triangle. Sine is opposite over hypotenuse, so that's going to be root 15 over 4. But because we're in the fourth quadrant, so we have a negative value. Cosine alpha, that's right, this one right here. So I'm going to look at angle alpha first before we move on to the second triangle so I don't get confused. Cosine is adjacent of hypotenuse, that's simply 1 over 4. Okay. Now moving on to the second triangle or second angle, beta. Cosine beta is adjacent root 21 over hypotenuse, which is 5. And because we're in the third quadrant, so cosine is negative. And for sine beta, it's opposite over hypotenuse. And again, because we're in the third quadrant, so sine is negative. Okay, so now we can simplify this a little bit here. 4 times 5 is 20. and we have negative times negative, so it's going to be positive, okay? Now root 15 times root 21, I believe you actually get 3 root, what is it, 5 and 7, so 35, okay? And then 1 times negative 2 is going to be negative 2, okay, so like that. Okay, if you don't know how I got 3 root 35, you can just simply put into a calculator. Or you can just leave it as 15 times 21. It will give you you need to use prime factorization. Okay, so I'm not going to go over that. If you need some help with that, let me know. Okay. Now we can subtract them. Now because it's a subtraction of negative numbers, so in this case we are actually adding up numbers here. So this is going to be 3 root 35 plus 2 over 20, and that's your final answer. Okay, so that's the first example. The practice question here is very much the same thing. Okay, so I'll let you try it, and I will show you the answer when you're finished. Okay, good luck. Okay, so hopefully this is what you got. You should get 2 times root 21 minus root 5 over 15. Okay, again, same procedure. Just get your 2 triangles set up, and then just apply the trig ratios for both of those angles. Okay. All right, moving on to the next page. We also have, as I mentioned earlier, we also have the tangent of alpha plus beta and tangent of alpha minus beta. Okay, so sum and difference of tangents. So they are actually proved similarly. Okay, so I'll let you try it. Just follow along with the proof on the left and see if you can figure out. Okay, so good luck. Okay, hopefully you got this far at least. Just apply the tangent being equal to sine over cosine, and then apply the identities here. Now the next step, you actually just do like what it did here. You just need to divide both sides by cosine alpha, cosine beta. Okay, so that's what we're gonna do. Okay, I'm gonna have sine alpha, cosine beta, divided by cosine alpha, cosine beta, minus cosine alpha, sine beta, cosine alpha, cosine beta. Same thing in the denominator, we've got cosine alpha, cosine beta, divided by cosine alpha, cosine beta, plus sine alpha, sine beta, cosine alpha, cosine beta. And the reason why we do this is then we can get rid, we can cancel the cosine betas. Here we got sine alpha divided by tangent alpha, which is tangent alpha, minus the cosine alpha get cancelled out, so we end up with sine beta over cosine beta, which is tangent beta, all over that's simply just 1, right, because everything cancel out, so 1 plus in this case you got sine alpha over cosine alpha, that's tangent alpha, and then you have sine beta over cosine beta, which is tangent beta. So notice how this identity is almost the same as the addition, the sum. Okay, the difference for the tangent is almost the same as the difference of the sum of the tangent, except the signs are just flipped, right? It was plus on the top, minus on the bottom. It's just the opposite. Okay, so hopefully you got that. If you didn't, that's okay. It doesn't really matter as long as you remember this. Well, actually, you don't need to remember. I'll give you the identity sheet at the during the test. Okay, so here we go. Example 2, we are looking for the exact value of each of the following. So this is what we mentioned earlier, okay? So we have to use special angles to find either the sum or difference, and then that will give us the angle that we are interested in, okay? So 13 pi over 12. In this case, what we can do is we can say that cosine it's going to be something plus something. Now I notice 13 pi over 12, we can do this as, what can we do? We can do 9 and 4. 9 pi over 12 and 4 pi over 12. Okay, notice you cannot do this one here. You cannot do 8 pi over 8, 8 pi over 12 and 5 pi over 12, because 5 pi over 12 is not a special angle. This won't work. You could do this one though, that's 10 pi over 12 plus 3 pi over 12. This will work because if you reduce these, okay, if you reduce this, you get 5 pi over 6. If you reduce this, you get pi over 4. which are both, well, either the special triangle, like a sort of special angle like that, or its reference angle is also a special angle. Okay, just like our case here, if we reduce 9 pi over 12, we get 3 pi over 4. And if we reduce 4 pi over 12, that's pi over 3. Both of these angles are either special angles or its reference angle is a special angle. Okay, so that will work. But again, this won't work. So not all the combinations will work. Some will, some won't. Actually, most won't. Okay, so you just got to pick the right one. Okay, so you could do this one, okay, or do this one. It doesn't really matter. Okay, all right. So now we can actually evaluate. So cosine, recall. Okay, I'm gonna zoom in a little bit here. Cosine is going to be cosine alpha plus cosine beta. Cosine alpha plus beta is going to be cosine alpha, cosine beta minus sine alpha, sine beta. Okay, so there you go. Same thing for fractions. Okay, now you need to use your special triangle. Okay, so hopefully you know your special triangles quite well by now. 3 pi over 4, the reference angle is pi over 4, so there's my pi over 4, 1, 1, root 2. And then I have another one, this is pi over 6, let's say, pi over 3. My triangles are not drawn to scale. Okay, so cosine 3 pi over 4, that is simply going to be 1 over root 2. But because we're in the second quadrant, right, remember 3 pi over 4 is in the second quadrant, so cosine ratio will be negative. Cosine of pi over 3, so that's adjacent of hypotenuse, that's 1 over 2. Sine over 3 pi over 4, that's again going to be 1 over root 2. And because in the second quadrant, sine is positive, so there you go, 1 over 2. Sine of pi over 3 is going to be opposite, which is root 3 over 2. Okay, and now we can bring this to here and simplify this a little bit. That's negative 1 over 2 root 2 minus root 3 over 2 root 2. Okay, which then we could simplify this to negative 1 minus root 3 over 2 root 2. Now we should not simplify, we should rationalize this by multiplying both sides by root 2, or not both sides, we only have one side, both numerator and denominator by root 2 over root 2. So rationalize it. So you should get, hold on a second, I better double check, see if I made a mistake. I always make mistakes, so better be careful. I don't want to remake the video again. Okay, so negative 1 times root 2 is negative root 2 minus root 6 divided by 2 root 2 times root 2 is going to be a 4. Okay, so there you go. That is your answer. Okay, now you can try part B. You need to, again, think about two angles that will make 105 degrees. Okay, good luck. All right, so hopefully this is what you got. You should get root 6 minus root 2 at the end. One thing you should notice here is that I actually didn't rationalize the denominator. I actually flipped the fraction first, and then I noticed this is the denominator I actually will get at the end, right? So then I rationalize this instead. Now this is a binomial, or it's two terms, right? So when you multiply when you rationalize it, you gotta multiply by its conjugate. Okay, so that's root 3 minus 1 in this case. Okay, this is the same terms except one's a plus, and now you multiply by the minus, so then the middle terms get cancelled out. So you should get 3 minus 1, which is just 2 there. And then just multiply the top and then divide everything by 2, you get root 6 minus root 2. Okay, so there is simplifying or evaluating right there. Okay, number 3, proof. Okay, so we've seen proofs quite a bit now, so I'm just going to show you this one here. Or you can try it if you want to. Okay, so if you want, you can pause the video and give it a try. Okay, anyways, sine alpha minus beta, this is going to be sine of alpha, I actually don't need brackets there, sine alpha cosine beta minus cosine alpha sine beta divided by cosine alpha cosine beta. Okay, and now because it's just one single term in a denominator, I can just divide the numerator individually. Okay, so I got sine alpha cosine beta divided by cosine alpha cosine beta. So notice you can cancel out the cosine betas, so you get sine alpha over cosine alpha minus, for the second fraction, both numerator and denominator has cosine alpha. So then you can cancel those two out. You end up with sine beta. Okay, sine beta over cosine beta. Now, sine alpha or sine A over cosine A is tangent A. Sine B over cosine B is tangent B. And there you go. That's it. Okay, hopefully by now you're getting more and more comfortable or used to proving trig identities. Okay, they're some of them could be tricky, but they're quite fun to do. I feel. Okay. Anyways, number 4, solving equations. Okay, we've seen this before. So here's the equation: sine 5x cosine 2x minus cosine 5x sine 2x equals to 0.5. I think I mentioned this to you earlier, that you can't really solve a trig equations with two different trig ratios, meaning that you can't really have sine and cosine in the equation, otherwise you can't really solve it. But in this case, what we notice though is that this is sine alpha cosine beta minus cosine alpha sine beta. This actually can be reduced or simplified to sine of alpha minus beta. And equal to 0.5, I'm going to write that as 1 over 2 because it's a special triangle, right? If we write it as 1 over 2. Well, what happened? So this is going to be sine 3x equals 1/2. So again, right away, I see 1/2. I know it's going to be a special triangle, so I'm going to draw my special triangle right here. Again, it's going to be 1, 2, root 3. I'm working in radian mode, so this is going to be pi over 6. This is pi over 3. Okay. Now it's not just sine x, it's sine 3x. So I think this is a review of 9.2. We would replace 3x with a. We can find the reference angle AR, and that would be inverse sine of 1/2, which is going to be in this case pi over 6. Right? That's the reference angle. And then we would go on to find A1, which is going to be in quadrant 1, so pi over 6, and then A2. We are looking at sine being positive, so we're looking at quadrant 2. So that's going to be pi minus pi over 6, which is 5 pi over 6. Okay. However, we are never told to solve for a. The question was always about x. So then we need to go back to the question and replace a with 3x. So a1 being pi over 6, so I rewrite that as 3x1 equal to pi over 6, which means divide both sides by 3, you get pi over 18. There's your first answer. And then 3x2 should equal to 5 pi over 6. And then again, divide both sides by 3, you should get 5 pi over 18. There's your first two answers. Now, hopefully you remember we actually will have more answers. In this case, we would have 6. And that is because it's 3x, right? So for each period, you should have, for every 2 pi, or for each period, you should have 2 answers. Because it's 3x, so it's compressed by a third, and therefore you have 3 times the number of answers. Okay, hopefully that makes sense to you. I think I might have mentioned this to you in 9.2. I can't remember. Anyways, it doesn't matter. You just need to keep adding period to get to go outside of domain, then you know that's when you need to stop, right? Okay, so we're gonna get more answers. And again, to get more answers, you simply take your x1 and add the period. Now recall, the period for sine and cosine are 2 pi divided by b. This is a sine function or sine equation, so it's going to be 2 pi divided by 3, which then I need common denominator of 18. So that's going to be 12 pi over 18. And if I add them together, I get 13 pi over 18. So there is my third answer. I can find my fourth answer by taking 13 pi over 18, add another period, which is going to be 2 pi over 3, and I'm not going to write that, I'm going to write 12 pi over 18 now, okay, because I know I need common denominator anyways. So 13 pi plus 12 pi is 25 pi over 18, and this is my fourth answer. If I add another period, I actually will get 37 pi over 18, which is more than 2 pi already, so I don't need to do that anymore. However, we still have the second answer, x2, and we can find x5 from x2. So taking the answer from x2, same thing, add the period. And I know the period is 12 pi over 18, which will give me 17 pi over 18. So there's my fifth answer. And for my final answer, x6, I'm taking 17 pi over 18. Again, add a period, 12 pi over 18, you get 29 pi over 18. And again, if you add another period, you are going to go outside of the domain, which means we don't need it. Okay, so there you go, 6 answers, as we expected. Okay, there you go. Here's the last example. I'll let you try it. It shouldn't be too difficult. You're simply applying the sum and difference identities here for cosine. Okay, give it a try. Good luck. I'll show you the answer in a bit. Okay, so at least you should get to this step. Okay, so again, be really, really careful. This is not the same as cosine x plus cosine pi over 6. Okay, you can't do that. That's a very, very common mistake. I know, but I mean, I'm just surprised to see that. Okay, again, these two are just simply the sum and difference identities, which you can find on the identity sheet. Okay, so don't distribute them because you're not distributing here. Cosine of that, you are not multiplying. You are taking cosine of an angle. Okay, anyways, back to the question here. Hopefully you notice that you got cosine x, cosine pi over 6. You don't actually need to evaluate this yet because you can see that this is also cosine x, cosine pi over 6, and because we're subtracting them, so they simply cancel out. And for the second term, you got negative sine x, sine of pi over 6, and you have subtraction, so minus sine x, sine pi over 6. So really, you have two of them, right? Negative 2 sine x, sine pi over 6. Okay, and now we evaluate. Okay, so we can simplify first and then evaluate. Now pi over 6 again is a special triangle. Let me just quickly draw it. Pi over 3, 1, 2, root 3. So negative 2 sine x. Now sine of pi over 6, so opposite over hypotenuse, 1 over 2. Negative 2 times 1/2. You should get negative 1, so your final answer should just be negative sine x, and that is your final answer after you simplify it. Okay, so that is all for this section. Yeah, again, it's more of the same thing, right? You prove, you simplify, you solve equations. That's it, okay? Hopefully, though, you are getting more and more comfortable doing these questions. Okay, so do some questions in the book and let me know if you need some help. Okay, otherwise, good luck. See ya.